Welcome back to Pal Science Experiments. My name is Mr. Miles. I'm going to be your Pal Science scientist for the next 5 or so minutes. So if you've been following this series, you know that we are trying to bring you some experiments that you can do with your family at home in quarantine using materials that you either already have or that are very, very easy to find at a grocery store. And today is no exception. So if you're ready to see a very, very cool experiment, one of my favorites, then keep on watching. So the reason I like this experiment so much is, number one, it's very easy to do. Number two, it is very impressive to see. And number three, it takes almost nothing as far as materials. So I'm going to go ahead and show you the materials we're going to use. So thing number one you're going to need is a plastic Ziploc baggie. Thing number two you're going to need is a nice sharp pencil. And thing number three you're going to need is access to water in some way, shape, or form. So rather than telling you what's going to happen, I'm going to go ahead and just walk you through the steps of this experiment, because another thing I think is fun about this experiment is that it's kind of a bit of a surprise ending. So if you're ready for a surprise, keep on watching. So the first step of this experiment is very, very easy. We're just going to take our bag and we're going to fill it with water. So I'm going to go ahead and turn on my very loud sink over here. Give my bag some water. I'm filling it about 2/3 of the way. You don't want to necessarily fill it all the way to the very, very edge. And now I've got my nice filled bag. So what I'm going to try to do is, you don't have to go crazy with this, but I'm going to try to kind of minimize the amount of air in it, because you really want to focus on the watery part of the bag, not the airy part of the bag. You don't have to go crazy though. It's pretty foolproof. But you want to make sure your bag is zipped up nice and tight. And now I've got a nice little bag of water. Ooh, squishy. So, if I've got a full bag of water, and I've got a nice pointy pencil, you can probably guess what we're going to do next. Stab it! So you have to be kind of quick about this, because as you can imagine, this has the potential to get wet. But if you're smart about it, well, how about that? So, it's a bit surprising that none of the water came out of the bag. I bet some of you thought it was going to spill out all over the floor. But there's two different things happening here that keep the water inside of this bag. Thing number one is the material the bag is made out of. So the bag's made out of plastic, which is a polymer, which is a fancy chemistry term that means a chain of identical molecules that push the pencil through. The sharp part of the pencil moves some of those molecules aside, but as the pencil goes through, the plastic wants to make a nice seal on the side, and it wants to hug up tight to the pencil, and it hugs so tight that it makes a seal where the water can't escape. And it's further held in by the surface tension of the water itself. So surface tension is kind of what happens when water likes to stick to itself, right? You've seen surface tension if you've ever filled a glass very, very full and it makes that little bubble. Yeah? So the same thing is sort of happening here. So because the water wants to stick to itself, even though there technically is a tiny, tiny little crack between the seal of the bag and the pencil, the surface tension of the water keeps it from bursting through that crack. So we end up having the water stay nicely in the bag. And I hope you have a great rest of your day.